Bam, what up, Yang Gang? Got a special guest for you guys. Her name's Cheslea. She's from where I live. And I'm just lucky enough to have a coworker who had a daughter who went to college at the right time to study virology, Cheslea, man. So thanks for joining us, Cheslea.
Yeah, thanks for having me, Boyce. I'm happy to be here.
So everybody's got a bunch of questions.
Okay.
But I want to start off with justifying the point of you being here specifically, and like kind of tell people your background and why you are here specifically.
Yeah, sounds great. So I got my undergraduate degree in chemistry, worked for a couple years, and then in 2015 I went back to school and ended up just graduating with my PhD in biochemistry this past March. And during my 6 years of my PhD, I studied viruses. I studied viral entry for all 6 years. And this past year, I've actually been studying COVID-19 and the SARS-CoV-2 virus and looking at aspects of entry with that. So I'm here to hopefully talk to you guys some about that and answer some questions.
Yeah. So I guess the first question is like, what is it about COVID-19, SARS-2? Why is it just so damn deadly? We know why it's so infectious, but why is it so deadly?
That's a great question. I mean, so as a scientific field, I'm not sure we know right now because we've only seen it for, I guess we're approaching 18 months now.
Yes.
And there are a lot of components to that. So one, just the sheer number of people it can infect, right? So we, in the field of virology, we measure how a virus infects people by a term called what we call an R naught. So in what that measures is for every one person that gets it, what's the estimated number of people they're going to infect? So for stuff like most seasonal flus, that R naught is about 1.7, 1.9. For things like measles, that R naught is 18. So there's a big range in the virology field. And this R naught is the R naught of SARS-CoV-2 we think is probably about 2.3 to 2.5. And so anybody who studied mathematics or knows about mathematics, that's exponential growth, right? So if you have one person and they're infecting 2.5 people, that's when those 2.5 people go on. And so just that sheer number of infection, and because it's causing respiratory symptoms and it's causing, other pathological symptoms in your body, things we maybe don't quite understand yet with some of the myocarditis that we're seeing, maybe in some neurological effects, you're going to have more deaths. And so it's interesting because in coronaviruses, we've actually seen kind of in all coronaviruses. So coronavirus is actually a term for the whole family of viruses. And there are several coronaviruses that we've all had in our lives that cause the common cold. And so we get them, we maybe get a stuffy nose, that kind of stuff, and don't really ever think about it. And there have been 2 coronaviruses prior to this pandemic that have actually caused larger scale issues. So SARS original in 2000, I think 2002, 2008. Yeah.
Yeah. Obama. Yep.
And so that actually had a much higher fatality rate. And so that was actually killing about 8% of the people infected. And then MERS in 2012, 2013, that actually continues to outbreak every year, was also very high in killing people. And so coronaviruses kind of have thrown the spectrum of getting it every year and not, having issues with the normal coronaviruses through SARS and MERS that were very deadly. And so this coronavirus just kind of falls somewhere in the middle. And so there's a combination of effects there.
Oh, yeah. So let's talk about the big ticket item right now is the Wuhan lab leak theory. So I know lab leaks happen. And that's one of the questions people are like, man, do you believe in a lab leak? I'm like, it's not a belief system.
Right.
Is there data to support it or not? And do you think it's more than likely to be naturally occurring in the wild versus a lab manipulation with the gain of function?
The gain of function mutation.
Yes.
So, I mean, that definitely is a possibility, right? There needs to be more research. However, as somebody who has actually studied some of the differences between this coronavirus and coronaviruses that have been circulating in a bat population in regions of Asia for several years, this is very similar. The genetic sequence of this coronavirus is like 96% similar. And some of the changes are changes that we have seen in other viruses that have spilled over from the bat population to a human species. That's a totally normal route of transmission for viruses. Bats make these perfect little reservoirs for viruses because they're mammals. They fly, so they have this broad habitat range. But so they're close enough to us to be dangerous because they're mammals, right? So they have some similarities. But they're so different. Their like heart rate is way higher, and there are people who actually study this, who study kind of the differences in why bats make these great reservoirs. But there are things about them that don't cause them to be infected or like have symptoms from these viruses. And so
capability versus being
right. And so there's, from what I've looked at and from what I've personally studied in my beliefs, I think this very much is a naturally occurring virus. It was in bats, and I think it spilled over to humans. The one, I guess, and I have no evidence for this, obviously nobody has evidence for this. The thing I think could have happened with the Wuhan lab, which I totally could see, is potentially they had found this virus and were studying it, maybe doing gain-of-function mutations. I don't know that we'll ever really know.
Right.
But they might have had some unsafe practices, who knows, and caused a small outbreak that kind of trickled out. But there's evidence of COVID-19 infections in lung samples from patients in Italy, I think dating back to like September of 2019. There are cases in different parts of Asia in November. And so there were definitely cases of COVID-19 in places prior to the outbreak, the major outbreak we think of in Wuhan.
So I haven't heard about the September in Italy.
There was I think they were doing research on like lung samples for like maybe a new drug or a new mechanism. They went back and tested them, and several of them tested positive for COVID-19. And I haven't followed up on that. That's a paper I read a while ago.
Okay. But yeah, that's the thing. Like I've heard different people say it's not as likely because it jumped species and increased this and had a couple different, it shouldn't have 2 to 3 new functions, I guess you'd say, gain of functions in one generation, I guess you'd say one variant.
Yeah.
But I believe, because I actually interviewed a guy in India, a young man in college, that there is a triple mutated COVID-19 variation called the B1617, I believe it is, that has significantly doubled the infection rate, primarily, like just for now, because they don't know enough, but significantly higher infection rate and not as deadly as from the preliminaries, So that's interesting, and that's why India had 300,000 to 400,000 cases a day until they shut it down.
Right. Yeah. These variants, I mean, viruses are not living things. They're kind of just little genetic envelopes, is how I think of them. They're little like mail envelopes up with genetic material. They need a host to survive.
Right.
But it's advantageous for a virus to have mutations that allow it to spread quicker from the life cycle of a virus. That is a totally normal route of transmission and viral adaptation we see in all fields of virology.
Yeah. Well, I kind of like compare, because like mosquitoes, people use mosquitoes for research because they have such a quick life cycle. Kind of like a virus of the animal kingdom, that they consume blood and they can inject them, and do experiments with them. And I'm fascinated by that too, because of the mosquitoes of, I think it's the Amazon, have a third of the life cycle of ones here in North America, because their life cycle is so short, they're more aggressive.
I had no idea.
Yeah, they're more aggressive because they have less time.
Okay.
So these suckers swarm you in the Amazon.
They got to get that feed meal to keep going.
Or their genetic code doesn't go on. It's an evolutionary thing. But yeah, I love this stuff, man. I love the science of it, and just to learn more. And let me think. What's the other question? So people were like, something I've been thinking about, because the flu, the influenza A and B and whatever the variants are, right? Those have all went down because of masking and all that stuff, because we've decreased the odds of it spreading. Yeah. Is it possible that COVID could outcompete the flu now? Because it can become like a replacement. Like, that's what people's biggest questions are. We going to do this every year? Is this going to be a seasonal thing? We have to start schools out in masks, and you know what I mean? Like, that's the biggest paranoia is reoccurring.
Yeah. I mean, so I think, so looking at viral competition, I don't know that I have a good answer in terms of it outcompeting the flu. The flu's been endemic in that we have a seasonality to it for so long that I really doubt it. I think what is totally feasible and really might happen, especially as vaccination rates go up, is I think potentially we might see a seasonality to COVID-19 and SARS-CoV-2. So much like we have a flu season, there's also an RSV and a human metapneumovirus season that are kind of similar to the flu, but a little off. And I really wouldn't be surprised if we start to see that with COVID, where every, fall, winter, we're going to have to worry about another viral pathogen in a seasonality.
Mm-hmm.
The hope with this is now, again, much like flu, we have a vaccine for it. And so while right now we don't know how long we're protected with the vaccine doses we have, it's something that's being investigated. And so worst case scenario, hopefully, and I mean, maybe I shouldn't say worst case scenario because, we are living in a global pandemic.
We're in the worst case scenario.
we're in it. But I would guess, if anything, we're going to have to get like a booster every year. And it's going to be a little different than the flu vaccine we get every year, because the flus have a strain component to it that COVID doesn't have right now. And so likely it would just be the same vaccine and you just get a booster every year. Maybe we might be protected longer. Mm-hmm. And then you wouldn't have to mask when you go to school and that kind of stuff. I do think as a culture, now that we've lived through a pandemic and seen that masking and social distancing and stuff works, I think we're going to be a culture that's a little less apt to go to work when we're sick now. And that may be similar to what we've seen in Asian cultures for decades, if not millennia now. When you're sick, you wear a mask when you're in public to help protect people around you. Mm-hmm. And I'm sure there are people that aren't happy with that, but it's just kind of a respect for your neighbors, for yourself, right? When you go visit your grandma and you have the sniffles, put a mask on, protect her.
Yeah. Wash your hands.
Right. We learned this year how to wash our hands. Let's not forget that.
It's really surprising how people had to be taught that, by the way, you've touched a public transit doorknob. Uh-huh. You might want to wash your hands. Just with some basic, just a little squirt, just a little something. Yeah. And don't touch your face. And the average person touches their face like 20 times a minute or something, Like,
oh my gosh, yeah.
It's not 20, but
I'm totally the victim of that. I mess with my hair. You'll see it in this podcast. I'm terrible at it, but I just wash my hands a lot and hope for the best.
Well, that's the thing specifically for women or men with long hair, it increases the rate.
Yeah. Apparently we should just go the Boyce haircut.
The special.
That's the way to go.
Yes. It is simple. But I think this has woken up some of us. We have half the country that's just now I won't say half. It's less than half now, because I think we're at over 60% has their first dose.
Okay. I haven't followed up on that to see where we are. I know the goal is 70.
It was 61% on May before Memorial Day. Before Memorial Day weekend, it was 61% had their first dose and over 49% had their second.
That's fantastic.
Biden's goal of July 4th, 70%. They're not
lofty.
They're close though.
Yeah.
But, that's just the first dose.
Mm-hmm.
And so I think the closer we get to July 1st, the more people might be incentivized to do it because of travel. So I think private companies can require it. Mm-hmm. And say, you're not flying here.
Yeah.
Sorry, and I mean, look out for employees.
Not even private companies, but countries can still dictate who they open their borders to, right? And so if you get on a flight to France and their border, you have to be vaccinated and show your vaccine.
Yeah, you're not going to care. New Zealand don't play.
Right.
Their prime minister, she's amazing. Please come to America.
Which is why they've had the fewest deaths, right? Like they've handled this well.
They had like 100 days in a row with 0 new cases. Uh-huh. I covered that. I was like, oh my God, 100 days.
I know.
We get 100 per minute sometimes, just in the country.
Yeah.
But then it showed that they went 100 days without nothing, and they had 3 new cases in a day. They shut the country down for 3 weeks, and that's it.
Yeah.
And they send people a stimulus income to say, pay your bills for the month. We're done. We're not doing it. We're not risking it. And they've had the fewest. I mean, plus they have some advantages of being an isolated island, and
right, and a much smaller population. Right, there are a lot of things that come into play then.
Same thing in Australia. All their cities are on the coast, and they're very spread out. And their whole middle of their country is just empty.
Right.
But yeah, there's some geographic advantages others have that we do not. We have borders, and we have good climate, and we have dense populations.
Yeah, we have a dense population throughout the country too.
Right. But nothing in comparison to India that I'm really nervous about India with their variants, because they provide, I think 60 to 70% of the world's vaccines are made in India labs. It's like 60%.
Oh, really?
I think it's over 60.
Okay, I didn't know that.
And so if they have a true pandemic, a regional one to their country, they're not going to go to work.
Right. They're going to be shut down.
We need their labor. Let's just be real. We need their labor to keep us all safe. So we all need to be making sure that India and anyone else that has a next outbreak, we should have 1 million doses ready to go. And that's something I actually saw Biden talked about, buying over 1 million doses and donating
I saw
to
that
other
too.
countries. So I'm good with that. I'd rather our tax dollars go to that than to Wall Street to prop it up and stuff like that, because of piss poor management of a pandemic. We won't get too political here. I'm trying to keep it science as much as possible. So another thing, let me go to the so there's been people I've been put out there on Twitter. I've been using hashtag trickle up Q's. So we're actually going to bring this up. There's quite a few questions in there.
Sounds great.
So we have my girl Kitty.
Okay.
She says, what do you think this fall and winter are going to be like with the variants? That's a total unknown.
Yeah, I mean, that really is an unknown. I am still hopeful that these vaccines will be effective against them, right? The good news is we're calling them variants, which means if you think of in the virology world, what we mean by variants is there are small genetic changes. If it was large genetic changes, we'd call them different strains. I think there's a cutoff in terms of like how much genetically different they can be. I don't know that off the top of my head.
So they like call it COVID-21 or SARS-3, you mean? Or
yeah, or like we love Virologist. We have like the simplest naming system in the world. So like we'd be like SARS-CoV-2 strain A and strain B is probably what we would do. People can maybe get a little bit more creative than that, but like pretty straightforward. But because they're variants, right now, I mean, I think Moderna and Pfizer are doing their due diligence and looking at these variants and how effective their vaccines are. And right now, I mean, they seem to be promising. There seems to be good hope that if you're vaccinated, you will also be protected against these variants. We could have something crazy happen and it could totally change. We could have a new strain pop up. In those dense populations, those are great spaces to make new variants because you're just transmitting the virus so quickly.
Well, I also saw that in Michigan specifically, let me move this out of the way. In Michigan, we had a little miniature outbreak of the South African, the B117.
Yep.
That kind of had a little bit of a run, and Pfizer did some preliminary studies, and it had about 50% effectiveness in the preliminaries. So
yeah. And I think we've gotten into this thing where we're like, 50%, maybe that's not that effective a vaccine. But the reality is the flu shot every year is close to that. 50% for a vaccine is pretty effing good.
Well, and that flattens the curve. That's all we want to do. Flatten the curve. 50% and masking.
Right.
Yeah. It's pretty good. Well, that's the thing. And it costs you nothing. It's more advantages from great research and development. Yeah. I love science. I just wish I would have went into a science field. I did with therapy, but
yeah, you're close.
I am fascinated with the human body too. So,
yeah. Hey, it's never too late to go back to school if you want. Ooh. I don't know that I would. I'm very glad I got my PhD. It's a lot of work. If you're unsure, it's not for everybody.
Yeah. I'm 45. I'm done.
Hey,
like
There's
starting
time.
over. I'm
There's
done
time.
starting over. I'll make some lateral moves.
Okay. All right.
Starting over, man. A PhD.
You could go for like a master's, right? 2 years. Or just take some courses for fun, right?
That's what I like. That's why I love YouTube. I can go look up stuff, and there's experts that can just break it down and save me 4 credit hours. Not like I'm going to get I can't pass a course, right? But it's just the information. I don't care to regurgitate it accurately forever and apply it in a lab. Just I'd like to know. But yeah, so the next question we had was, this one's a more opinion piece. Is my buddy Michael with Resist for Humanity says, how will history judge America's response? I will say it horribly.
Yeah, horribly. I mean, it depends on whose history you're talking about. In my opinion, America likes to not be so harsh when we judge our own history. And then we tend to repeat it, make similar mistakes, that kind of stuff. But for lack of a better term, we fucked up several times on this. So I think there are lots of lessons we can learn from, like you just said, New Zealand's COVID-19 response. They did a great job. Australia has done a good job. I think there were a lot of things we did wrong. The biggest complaint I have for how we started at the beginning is from the beginning of this pandemic, we politicized it. People getting sick from a virus is not a political issue. I don't care who you side up with, whatever. But the minute we politicized it, which was March, February, January, right? Like somewhere in there. And that, I think it was all downhill from there.
That's 101 right there. That's basics.
Yeah.
A virus does not care about
it doesn't care.
Demographic.
Doesn't care about your race, doesn't care about your
It doesn't
beliefs.
check the census records.
No.
It just says, hey, you are the host that I could live in. I think I'll use you to propagate my future generations. That's all there is to it. But yeah, I think historically, on a serious note, it's going to be a lesser, it won't be such rosy colored, glass. There's revisionist history, but we lived it. We will know the truth that we were not leaders in the field.
Yeah. And I think it's interesting to note our response is about 100 years after the last global pandemic, right? And so we're a whole generation away. There weren't many people who lived through both.
Right.
And so it's kind of a long enough time that we kind of forget the lessons that were maybe learned. And so we just have to remember to pass on that knowledge to the younger generation so they maybe don't have to live through this in 100 years.
Well, the good thing is we have an easier way of spreading the information through video because people don't like reading.
Right.
Let's be real, because average Americans, I think it said, read between a 7th and 8th grade level on average.
Wow. I did not know that.
It's not nothing to brag about. And most people are comfortable reading a grade or 2 below because they don't like to be challenged while reading.
Right.
So I think video is about as easy as it gets to get a point across, and even easier is a meme.
Yeah, a meme,
yikes.
A GIF, a TikTok, all kinds of stuff.
Yes, but now we have more ways of hopefully educating people. But I guess the biggest thing now too is people's fears, because now the media is propagating it as just a clickbait thing, and want to beat a dead horse to death. Now there's this Delta one that people have asked about in the rising and the questions is, what's your views on, what do you know about the Delta variant? Which
I have no idea. I'm going to Google that really quick because I really don't even know that I've heard of that one.
Yeah, I've just heard about like 2 or 3 days ago. The Delta variant.
See what this means.
Yeah, COVID Delta variant. It's in the UK.
Okay.
Wait a minute. It's the one from India.
Okay, so it is the Indian variant.
So it might be the double and triple mutated B6117. Just increased infection rate, but lower death rate. So just quick spreading, but it doesn't really kill you, which that's a perfect virus. The higher the infection is and you don't kill your host, that's a win-win. It's like a mosquito. A mosquito is a viral thing. It doesn't kill you; it just bites you.
Yeah, as long as it gives you enough to have immune protection, right? That's really all you need.
That's very true. Malaria is not a good thing for mosquitoes. Is like they tend to kill people. But yes, there's a deadly side effect of that. But yeah, like the Delta thing it's being renamed. So that's confusing when it says Delta. It doesn't say like the actual. Is that considered a strain 6117?
It's not. That's again just a variant. It's just a way to measure kind of what the changes are. So we've had the genetic sequence of SARS-CoV-2. I think China released it in like January, maybe mid-January to everybody. So we got it then. And so since then, there's kind of been a worldwide running database of what strains do you see, what changes are they, that kind of stuff. And so this is whatever naming system they have. This is that variant that falls into that. And so likely,
it's like when they name it, like B117, then there's 6117. Does that mean is that like a sequence in the genome where the branch variant comes from?
So
like almost like dominoes, you gotta have the double six to make the spindle type of thing.
So I don't actually think that's how they're naming them. I'm not positive. What they probably did is they have like a family tree. So like think of it as like they have a strain that they first called A and B. Mm-hmm. And so if they found a genetic sequence that was B with one change, they called it B 1.1. Right. And then if they found a strain of B1 that had a change, it was B1.1. And then they started, and so it just kind of has this family tree where they continue to map out how it fits.
Yeah, it's a numeric family tree then.
Right, exactly.
Gotcha. Okay. Yeah, that's okay. So, and also Carnage says not everyone does variant testing though, right? Like not everybody has access to those testing resources.
Yeah. I mean, usually when you go get your COVID test, I don't think they're testing for specific variants. That might have changed a little bit as we're starting to see these new variants, and in that public health departments might actually be sending that data out to get those new variants, or just maybe every once in a while kind of pulling to say, okay, hey, we have these positive COVID tests. Let's see what genetic strains they are.
Yeah.
But right now, if it's
or like in the UK, they had a spike. Like, something's different. Check the population. Maybe that's how they
exactly.
They got to have a trigger mechanism to make them use the resources up. Yeah.
Right, because I mean, it is a cost to somebody.
Yeah. Let's see here where to go. Okay. So this is from Heidi, one of our friends on TikTok. What vaccination is best for people that have had bad reactions in the past to vaccines?
Well, so Boyce and I were actually chatting about this earlier. It's this. We're at this beautiful point in science where we have a brand new vaccine technology. So both Moderna and the Pfizer vaccine use an mRNA vaccine technology that's never been used in a human vaccine before. And so the hope is if you've had a bad reaction to a vaccine in the past, you shouldn't have those reactions to this. I want to put that with the caveat in that you're going to have an immune response, hopefully, to this. So maybe it's after your first dose, maybe it's after your second dose, but you're going to have a fever, you're going to have chills. Like my first dose, I felt nothing. After my second dose, I definitely had a fever. I had body aches for about 24 hours. I was so tired. I took like a 3-hour nap after work that day. But that's my immune system working, right? I knew that was my immune system making that. And not everybody has that. But I wouldn't consider that a bad reaction to the virus, right? Or a bad reaction to the vaccine. I consider a bad reaction to the vaccine like you're going to anaphylactic shock or something like that. And this, obviously, there have been documented cases of that happening, right? They are prepared for that and that they've had some allergic reactions. But if you have a history of bad reactions to vaccines, this one should be different, at least the Moderna and the Pfizer.
Well, and so here's the big thing, guys. The most people have allergic reactions to it is because they're allergic to eggs, because most of the vaccines. So does that mean Johnson & Johnson uses egg whites still? Because they're not.
They don't. mRNA? So they don't either. But that one is a technology that's been used some in the past, and I don't know how often people have had bad reactions to that vaccine. But there's on a lot of vaccines you get, there's like are you allergic to eggs? And a box you have to check. And none of these will have that. None of these are grown in eggs to produce the vaccine. So that's good. If you're allergic to eggs, you can still get this.
Okay. And what's the other one? It's a Moderna and AstraZeneca.
AstraZeneca?
AstraZeneca. There we go. That's out of England, right?
It is. Yeah. University of Oxford develops that. And so AstraZeneca and the Johnson & Johnson, they're called viral vector vaccines, and they're fairly similar. And they also shouldn't, I'm not positive on the AstraZeneca, but I also don't think that's produced in eggs. So again, shouldn't be the same worry.
So you've been vaccinated. I've been vaccinated. I got the Pfizer one. I don't know what you got.
I got Pfizer. It was what was available.
So if you were to say, Chelsea, you get to pick which one you get, which one will you have chosen and why?
Okay,
what
great
advantages
question.
Does some have over others?
So this is, I guess, me maybe being, since I have the luxury of picking in this scenario.
Right.
I would pick Moderna if I had the option. And that's for a couple of reasons. One, Pfizer and Moderna are very, very similar. They use the same part of the virus. They're the same technology. There are a few probably proprietary aspects that are different between the two. But one of the main differences is the dose of, so the antigen is what it's called. But in a vaccine, the antigen is what your body is going to look at to make antibodies to.
That's the spike proteins?
It's a spike protein in this case. That's beautiful.
Gotcha.
And so the dose of the antigen in this case is about 3 times higher in Moderna. And so similar to kind of how your body makes antibodies, if you have a higher dose in there, it's probably going to make more antibodies. I'm not sure I've seen a direct comparison of how many antibodies are produced in Moderna compared to Pfizer, but if I had a choice, I'd get Moderna because of that higher dosage.
Right. So is there any kind of correlation between higher antigens and worsening like 24-hour flu-like symptoms to your immune response? Or is that just more like individually? Like I had the only thing I had was like a headache, and it could have had nothing to do with it. It could have had dehydration.
Right, or like a pressure change. Yeah. So it depends. If you already have antibodies, so say you already have COVID or have already had COVID and your body made antibodies, or on your second dose, if you have a ton of antibodies and you see a high dose, your body's going to have a stronger reaction. In most cases, everybody's immune systems are very unique and respond differently based on a whole onset of things. But the kind of very dumbed down baseline version of how your immune system works is you expect to have a bigger reaction if you have more antibodies and a higher dose.
Yeah, it rings more alarm bells, right? Chemically.
Right.
There's more,
Yeah.
Because I believe once they find that spike protein, it sends a chemical response to make. So, how does mRNA vaccine works? What's the mechanism? How the hell does it do this? It's amazing.
So it's this fascinating thing, which I can talk probably for hours about, but for the sake of people on this podcast, I definitely won't. But so the way our cells work and the way our cells make things, we use RNA. So our genetic code is stored as DNA in our cells, and we want to make something. So say we want to make, I don't know, an immune response. Say our cells want to make something. They take that DNA genetic code and make it into RNA and make whatever that RNA encodes for. And so in vaccine history in the past, instead of having our bodies make those proteins, we make those proteins or cellular components in a lab, which costs a lot of money to produce those. So like things they can make are like antibodies. So if you make antibodies in a lab, that's a very expensive process. And so once those are made in a lab, in traditional vaccines, they can, inject you with those. In the mRNA vaccines, they don't have to put the upfront cost into making those proteins because your body is this beautiful factory that has all the machinery to use that mRNA genetic code to make whatever we tell it to. And so we're just giving our body the tools and the sequence to make the spike protein. So this mRNA, which very rapidly degrades, but it'll go into our cells. It'll pick up our host machinery. Our host machinery will read the mRNA, it'll make, in this case, the spike protein of the virus. And so then we'll have a small subset of cells that will express the spike protein. And our little immune systems will be like, hey, what's that? We don't know that. We're going to fight that off. And so they make antibodies and so they can keep it in our immune memory to fight that off. And so we've kind of taken out some of the upfront cost of vaccines where we don't have to produce things in a lab because we're having our bodies produce them.
Right. We are the lab.
We are the lab.
Nice. Like, so that means that when it was genomed out, then you can say, okay, this is the spike protein sequence.
Yep.
And you take that sequence and I'm not saying a CRISPR-9 type of thing that just says edit, since it's okay, this is what we want to make the stop and start sequence, whatever that is. I know there's like a start and stop sequence for the DNA.
Yeah, they're called codons, but you make like your start codon and your stop codon.
Yeah, and well, if you don't have a stop, then you got cancer, right?
Yeah, in some ways there may be more components to that, but we won't get into that today.
Very basic stuff for me. I'm just trying to explain it, but from the physical therapy point of view, but just uncontrolled reproduction of a cell causes a tumor. That's a basic of it. But so pretty much they said, okay, snip, this is the spike protein, and so they just take the actual spike protein sequence. That's what they inject. Damn.
And so our cells, because our cells don't normally take up DNA. So for example, like apples have DNA. So when you eat an apple, your body doesn't take in apple DNA into your cells.
Right.
So they have taken this mRNA and put it in a little lipid envelope. So our cells have these envelopes that are made of, they're called lipids. You should just think of them as little fats that kind of contain your cell.
Yeah, fat cell.
And so this mRNA is in a little cell pocket that kind of tricks the cell into taking it up. And so this DNA is not getting incorporated into your DNA. Once the cell uses its machinery to read it, it just goes away. The only thing left in your body will be that spike protein, and your immune system will fight that off and make an immune memory to it.
It's amazing.
But that's all we're doing. That's all it is.
I really got fascinated with gene editing with the CRISPR-9 TED Talk I watched. I was like, what? Like we can make blue eyes green, and then it talked about sickle cell and. Well, that's one of my questions is, with this new technology, how can this be applied possibly? We don't know, but what advantages does it give the future scientists? Now, people like you are just getting into the field and say, okay, I'm going to try it in this setting, like cancer or whatever, right? Because it's all wide open now. Yeah.
So this is a technology. And actually, so research has been part of why we got a vaccine so quickly. I know that being a year and a half into a pandemic doesn't seem quickly, but the fact of the matter is vaccines take decades to develop.
Yeah. Minimum 5 years is what I heard in the past is the fastest.
Yeah. And so the fact that we have one a year and a half after finding this virus is incredible. But now that we have this technology, so it was researched for decades in other aspects of looking at this vaccine. And that's kind of how we had this stepping stool and this leg up to say, hey, we can use this successfully. Let's do it. And so it opens up this space in that we have a proven instance that mRNA vaccines work against viruses. Does that mean it's going to work for all viruses? Absolutely not. This, I think, will change the vaccine landscape. The vaccine landscape in terms of how we vaccinate against viruses has been fairly stagnant in terms of science. We haven't evolved that quickly in terms of the technologies we use. This is like one of those like field changing breakthroughs is the use of this technology. And so I think we are going to see it applied to other viruses. What those will be, I don't know. But like we don't have a vaccine for RSV, which is a huge problem for young children. We don't have a vaccine for HMPV, which kind of falls into the same category. Maybe looking at like flu vaccines, although there are other complications with like a all-purpose flu vaccine. But I do think it will change the viral landscape in terms of what we can vaccinate against.
Okay, then Cheslea, you've just gotten a grant for X amount of dollars to start your own lab. You have this technology now. What's your goal? What's the first thing you want to tackle with this new technology? What would you apply it to? Hopefully with success.
Yeah. So prior to, I guess, May of 2020, I was actually studying RSV and looking at viral entry of RSV. And so that is very near and dear to my heart. There are additional complications with RSV in that as a field, there are aspects we don't understand in that we've had since 1960, we tried to get a vaccine for RSV and it's been woefully unsuccessful. So who knows if this mRNA technology could be applicable to that, but that's what I would focus on.
Well, RSV is a respiratory virus. I can't remember what's the S stand for.
It's called respiratory syncytial virus.
Okay.
And so anybody who's had a kid in the winter has probably heard of it. We all have had it by the time we're 5.
Is that like whooping cough kind of thing, or is it?
It's not in that. For most adults who get it, it's going to be like a runny nose, maybe some congestion, like an upper respiratory tract infection.
Mm-hmm.
The big risk is to small children, and especially like premature children born in the winter months. That's kind of the season of RSV. It's a huge cause of pneumonia in them. Like lower respiratory tract infections can cause hospitalizations, bronchiolitis, that kind of stuff.
Yeah, so viral pneumonia.
Yep. Mm-hmm. Yep.
Okay, so we have some more questions in our little
let's go.
Cues. Okay, so there's some questions about people with other considerations, right? So are there other complications to consider with getting specific vaccines versus getting a vaccine for people that have kidney problems, immunocompromised, liver failure, whatever, like besides just diabetes and all that kind of stuff that's been shown to be COVID is deadly to those people. Right. So I think the vaccine is less deadly, but I mean, like, are there other considerations for these types of vaccines that might affect someone else more negatively with like kidney failure or whatever?
Yeah. I mean, so obviously that's complicated, right? Because there are so many different, other conditions out there that might impact this. But kind of, as you mentioned, COVID is probably far worse for those people. And you're going to have an immune response. Right, That's the whole point of getting vaccinated. And so hopefully there shouldn't be additional major side effects and that kind of stuff. But the reality is you should have an in-depth conversation with your healthcare provider if you fall into one of the categories and have a very candid conversation about it. Do your research. Obviously, if you have specific questions, I'm happy to answer them. I think you have my Twitter handle that you're going to put up eventually. But if
you guys want to follow her on Twitter, this is her Twitter handle.
Yeah, I'm not super active, but if you have questions, I promise I will try my best to answer them. But if I had a family member that were immunocompromised or on dialysis or something like that, I would encourage them to get vaccinated.
And so, what's the other one? I had one because there was a question about the kidney. The thing is, kidneys and liver isn't part of your immune system. So I don't see how that really compromise outside of just having some other complications that come along with that would suppress your immune system. But kidneys and liver doesn't really, it's a shot in your arm,
Yeah. And I mean, if there's an instance where you couldn't deal with the symptoms for a day or something like that, right? Obviously that's, or if the vaccine is, if your immune system is so compromised, your doctors are confident you're not going to make an immune response to it. That's also something, right? So cancer patients who are undergoing chemo, your doctor might recommend you wait till after. I don't know those questions. I don't know those thoughts.
Yeah. Rheumatoid arthritis has immunosuppressors, lupus, all those type of immune system stuff. The next question is a little more of a personal one to a parent from Grateful Sea Dog. She says, what do parents need to know about the vaccines for immunocompromised 3-year-olds?
Okay, so that one's a little lofty because we aren't approved for young children yet. I think Pfizer is hopeful they're going to get it by the end of the year.
They're testing right now under 12, Pfizer.
Okay, yeah. I think I saw an article that they're hoping for the 2 to 11 range by November. I'm not sure we'll hit that. But they've moved a lot faster than I've anticipated the whole time. So we could be, again, kind of along the similar lines. I would recommend obviously talking to your healthcare provider. If you have an immunocompromised child, I'm sure you have a very close relationship with that person. So they're going to be your best source of information. But again, what COVID and the unknown surrounding what COVID might do, a COVID infection might do to your child, if it's available and shown that it's safe for children, from that 2 to 11 range, I would recommend they get it. If it were my niece or nephew, that's what I would recommend.
Well, that's my big thing to tell people: risk analysis, right? Risk
Everything
reward.
we do has risk associated with it.
What's the risk? The possible side effects of getting the vaccine? There's something there. What's the risk of an immunocompromised 3-year-old of COVID? Significantly higher. Immeasurable. No one would want to take that risk. So this seems like the logical decrease in risk analysis. It's just there. Like my kids ask me about, aren't you nervous to go skydiving? Aren't you afraid of dying of skydiving? I was like, no, I'm afraid of dying on the way there in a car. Because statistically speaking, I'm more than likely to die of a car accident than jumping out of an airplane.
Yeah. Everything you do, you assume risk with. Everything you do.
The stairs, get in the bathtub, it's wet. Risk analysis, But anyway, yeah. So the vaccine is always safer than actually contracting the virus. Period. So that's just the big one. Let me see. Compromise. A lot of things about immunocompromised stuff. So where'd it go? There's one more left at the bottom that wasn't about that. Oh, and do you anticipate international restrictions on travel for people that don't get the vaccine?
I would. I mean, I think until we understand kind of what a post-pandemic world looks like, I'm going to assume there's going to be travel restrictions or potentially that you would have to mask consistently. But unfortunately, I guess I can be fairly candid on this. I think America has done a good job at screwing a lot of international relations over the past several years, including our response to this pandemic. And so I have to imagine a lot of countries will keep those restrictions in place for that reason as well.
I wouldn't
not saying please don't have Americans go, but just like you're unvaccinated and American, like we're not gonna appease you.
You're like the international meth head of travel, like not easily trusted. That's crazy, man. But
and I mean, I do think that being vaccinated is something, right? Like any kid who's gone to public school has had to be vaccinated against MMR. These are I know it seems weird because this was politicized so early in that, if you get the vaccine, you're a liberal, whatever. But the reality is this is not a new thing for our country.
Every parent that had a child go to public schools has to bring their shot records with MMR and now chickenpox.
Right. Yeah.
That was added.
Yeah.
Pretty recently. So you didn't seem to care about that one because chickenpox is real. We've all experienced it when we were kids. Now we don't have chickenpox anymore.
Right. Yeah. My first birthday, I had chickenpox, and now I'm like, oh, I could have not had that. That would have been great. I still have scars on my little head.
My hillbilly family, we had a cousin get it, and we had a
Did you have a chickenpox party?
We all said, make sure you guys all share the same pillow. Only send half as many pills as kids, literally. So it was me and my brother and my sister. My sister was too young, so we were like 5 and 3, maybe 6 and 4. So I was in early elementary school, and we missed a week of school. That was it. The fevers. It's actually miserable with the pox, and there's scarring and stuff. But like we literally kids die of chickenpox. Like we just didn't know about it as much, like we didn't know.
Yeah.
And now we know, like, no, don't give your kids chickenpox on purpose. That's an increased risk of death. Like, why would you do that?
Right.
But I'm fascinated by all this stuff. We have some more comments here or some questions in here.
Okay.
Where'd it go? Hot Sauce had one here. Okay. He's more the anti-vax guy. Like, how do you approach these people? What do you tell people propagating not getting the vaccine?
I mean, it depends on how feisty you're feeling, I guess.
I'm very feisty, and hot
Yeah,
sauce
what?
is too.
You?
Yeah.
No, I mean, so I think one of the things is they're gonna have to mask a lot longer. Like, I guess baseline, right? If you want to stop wearing masks, if you want to be under restrictions, there's a simple way to do that. A simple, free way
There's
to do
your
that.
freedom of choice, right there.
But I also just think like if there are some, well, this is maybe too complicated for the last 10 minutes of the show, but I mean, there are some cases that they're calling breakthrough cases of people who've been vaccinated who didn't mount a good enough immune response that can get COVID, and those tend to be older people. And so people who aren't getting the vaccine, if you have loved ones that are older or immune compromised, maybe their immune system can't make that immune response, you're putting them at risk when you go around them if you're unvaccinated.
Yeah.
And it's one of the reasons I got vaccinated. I want to see my 92-year-old grandmother. And I was never going to go see her without being vaccinated.
Yeah.
Or self-isolating for 2 full weeks.
Yeah.
So that's my best advice. I mean, I think it's good to have a conversation. It's good to be respectful and having that conversation, which I know is hard to do in the current landscape. But I think just talking through the risks of not getting one.
Yeah. And this hot sauce again, is COVID here to stay? Is it something we're always dealing with now?
So, I mean, time will tell. That's kind of a shitty answer.
Thanks.
Yeah, but I really do think.
Come on, man. No.
I do think there's a chance we're gonna see a seasonality to it, especially if we can't get those vaccination rates up. If we can get a population that's vaccinated in a perfect world at 100%, I don't think it would be here to stay.
Yeah.
But I don't think we're going to get to that, right? We don't get to that with other vaccines in this country. And so I do think we're going to see it. Kind of as I mentioned earlier in this podcast, or earlier in this YouTube, though, is that we might have to get a booster every year. But likely, if you stay up on your vaccinations and kind of understand the political landscape, it's not going to be the same situation that we're in this year.
Right. Hell no. No.
No, you're going to be able to live your normal life. So you're going to be able to go to the grocery store without a mask on. Maybe Costco will bring the samples back, right? You just going to have to be more cognizant of those around you, staying up, getting those boosters as needed. Who knows, though?
Yeah, we still have a population that doesn't seek medical advice ever unless their children die. So there's always going to be those psychopaths out there that are derelicts of parents that let their kids die of a basic fever and refuse treatments and just pray for them. I'm like, son of a bitch. That pisses me off actually quite a bit.
Yeah. And that's a personal choice, right?
Yeah.
But my big thing with that is don't put other children at risk if that's a choice you're going to make. Don't put grandparents at risk. Don't put.
That's a question I have then. That's something I've been kind of chewing on myself for the past couple of months. I think public schools should require all staff, all students, just like MMR, COVID-19, unless you have a medical excuse, not some stupid thing you download and laminate and hang around your neck like a freaking moron, an actual medical excuse. You should be getting it.
Yeah. I mean, so I think that's going to be a tough sell. I think the one thing that will help with that is keep in mind that our vaccines right now they've not technically gone through the full FDA approval.
Right.
And so they just have emergency use approval, which obviously has saved thousands of lives.
Yes.
And I think all 3 vaccines, as far as I've read, will seek the full FDA approval, which means they've kind of been fully vetted, had their full results reported and reviewed by the FDA panel. And I think prior to that, though, we do have to respect people who feel like they don't want to be guinea pigs or however they view it. But once we're at that point, if we're still seeing a regular seasonality to COVID, it seems reasonable, right? Everybody who works in healthcare has to get the flu shot every year.
Yeah. So that makes sense that it's not reasonable until we have all the data. the study.
Exactly.
Yeah. So
we have to be data driven.
We are all about the data. That's why I love my Yang Gang people. I mean, we love math, we love numbers and data. We have a guy in San Francisco. His name's Tom. He's called Nerds for Yang. All he does is data dives, and he's like, "This is the traffic on YouTube search engines," and like he does literal awesome data.
It's fascinating to see that kind of stuff.
Yeah, like he would do like the debates and do like live, like, hey, when Andrew Yang said this, look at the spike in search in 15 minutes. It went up 1,000% search of Andrew Yang because of this response. Like he literally, that's what social media does.
Yeah.
But with algorithms, and Tom does it live, man. I love Tom, man. But anyway, yeah, we're big on the data. So the last thing I'd like to cover is conspiracy theories.
All right, let's do it.
My favorite nut jobs. So this is on Forbes, guys. Forbes.com. If you want to see the whole article, I'll actually I'll drop it in here real quick.
Yeah. Note the title says debunked conspiracy theories. Debunked. Says debunked.
Here we go. We'll highlight it.
Perfect.
So top 5 theories, or conspiracy theories. 1, the vaccine includes a microchip. Go ahead and just once and for all smash this one down if you don't mind.
Guys, you know how much that would cost? There's no way. Also, if you're really that concerned about a microchip, I'm going to assume everybody is maybe watching this on one of these.
Mm-hmm.
You already have one in your pocket. They're not going to put one in your arm. It's way too much money.
Well, and a microchip's with the size of a grain of rice. That needle isn't thick enough.
Yeah. Anybody's gotten this vaccine, you're getting you don't even feel it for the most part. It was very quick.
I didn't. Yeah, a microchip requires like a plunger of a needle. You can see the actual cut in the needle. Like it's a big needle for any kind of injection.
Bill Gates is going through a divorce. He's not going to spend money putting microchips in everybody. He's not worried about that.
They already did it with Apple, man. Like these cell phones track everything you do, man. So yeah. Okay, that was fun. The vaccine alters your actual DNA.
No, it doesn't. So it uses the same as we talked about. It uses our cells' machinery because we're little factories, but it doesn't incorporate into us at all. There's no crossover event there. It doesn't incorporate. There's no risk of that.
Yeah, it doesn't take your cell and change its DNA.
It sure doesn't.
The readers read it and reproduce it.
Exactly.
That's it. It's like a copier.
It is. It's exactly what it is.
Yeah, it just scans it. And mutations come that's where the mutations come naturally in that process. But that's a mutation, not a manipulation.
Yeah,
that's not
the basis of this virus. It actually brings in it doesn't even use your cell's machinery. It like brings in its own. And so the machinery in your DNA is pretty good. It's got some proofreading ability because we're not like growing third arms on a regular basis here. We have good cell machinery in our DNA. But the viral one is less good, which is where those variants are coming from. Yeah.
But like this wouldn't create that situation. It's just not it's not in the science.
No, not at all.
Here's the one I didn't know about. Like I was telling you earlier, the vaccine can be shed, quote unquote, from one person to another. In other words, you can contract the vaccine.
Oh, no, there's no, you would need a live virus or at the very least a live bacteria to do that. And you don't have that in this
live virus, guys. Like giving you the actual virus.
I guess let me put the caveat: the Johnson & Johnson vaccine is an adenovirus vector, but it is non-replicating. So it uses a virus that isn't infectious to us, puts the SARS-CoV, the COVID-19 spike protein on the surface of that. So your body, it looks like a virus. It sees the spike protein, makes antibodies to that. But that virus cannot replicate. So you can't make more of that virus inside you. It doesn't replicate. Yeah. It infects you once, and that's the end of it. And so it just can't happen.
One generation. That's it.
Yep, that's it. It does its job, and then it's like, I'm out.
Yeah, I'm dead. And it's over. Here's the next conspiracy. The vaccine is causing COVID-19 variants.
Yeah, so because it's not using the same machinery, so like the virus inherently because the virus, as it replicates inside your cells, it uses its own machinery to make new copies. So everything it wants to make, it kind of brings in to your cell itself. And as I just mentioned in the previous one, the machinery it brings in isn't good at proofreading. So as it's making new copies, it's like, oh, I missed a mark there. Who cares? We're going to keep going. We're going to still make stuff. And that's where the variants are coming from, is when it's missing, misspelling a word. Like, think of somebody editing a paper and you miss a period and you use an A instead of a B and that kind of stuff. That's what the virus is doing. And so the virus is inherently doing itself. The vaccine presence doesn't seem to have an effect on that. We are not at a level where we're like trying to escape from the vaccine, that it's just not changing that rapidly.
Yeah. Okay. Then the last one is the vaccine has already led to a large number of deaths.
Oh, yeah.
By Tucker Carlson and Republican Ron Johnson of Wisconsin. Thousands of deaths are listed on the CDC's VAERS, VARERS, Vaccine Adverse Event Reporting System.
Yeah. So, friends,
Let's
just
explain
kind
that.
of some scientific insight to what this reporting system is because this is a brand new technology. I actually think they might do this with all vaccines. I'm not positive. But because it's a brand new technology, they want to be able to track trends of side effects, symptoms, if this were actually causing deaths. So anybody who's willing to report, I have done this. After you get the vaccine, they send you a little survey. Like, hey, how do you feel this week? Hey, what are you doing? But they're also keeping track of people who die. And so in our country, X number of people die every day from car accidents and heart attacks and strokes and falling off roofs and fluke accidents, right? And some of those people, because 61% of Americans now have the first dose of the vaccine, some of those people have the vaccine. But because it's being reported in this adverse tracking event, that is showing up as a death as somebody who's gotten the vaccine. That does not mean it's caused by the vaccine.
Well, that's the thing too. I like to use this example for the exact same thing is suicides are counted. Yeah. I've had COVID. If I kill myself, I will be listed on this list. Yeah. It's because they just want to know that I've had it. And now, if everybody gets it, then all of a sudden there's a rash of suicides that may cause suicidal ideations, right?
Right. They would look into that more.
Right.
Or if everybody who gets it is reporting severe, like, hospitalization headaches 3 weeks after or something, right? They're trying to track information like that to make sure, because this is so new, that this isn't causing something like that. I think the system is actually how they found there's a very, very small link to, like, blood clots in women under 50 with the Johnson & Johnson vaccine.
Yes.
Like, there's a very low risk of that, but this reporting is how they found that.
Well, same thing. I think it's with some neurological plaques, and I think it is hardening of the artery walls in some people, risk that too, but it's unknown. We don't know what mechanism is causing that.
Right.
Or it could be nothing to do with it at all.
Yeah. It could be how your immune system responds. I mean, it could be a million things. We don't know enough yet.
An infinite amount of possibilities in our body. That's for dang
truly.
But yeah, I thoroughly enjoyed this. If you got to go, it's cool. It's 10 o'clock.
Yeah, I got to head out soon.
Yeah, it's 10 o'clock. So you guys definitely go if you want to see what she's not on Twitter very much. She's a youngster.
I'm not, but if you guys have questions, please reach out to me on there. I will get back to you. I will do my best to answer your questions. I don't know everything, but I can be your scientific guide to good information.
So you can be like my Neil deGrasse Tyson of COVID.
Ooh, that's like a pretty lofty comparison there, but I'll do what I can.
I'm a big fan. Well, what's he call himself? The neighborhood astrophysicist, or
something like that.
Everyday
I can be your neighborhood virologist.
That's right. I have your number now. It's awesome. No.
Perfect. Yeah. Unfortunate for me, maybe. No, I'm just kidding.
Yeah.
I'm just kidding.
Oh, I will use it if I have a huge big question. But yeah.
Yeah, do it.
But yeah. Whoa. This is the people we're talking about, man. Thanks for the super chat, dude. Thanks for bringing your expertise to the general public. I'm not vaccinated, but if necessary, would it be appropriate to take the Sinovac or Johnson & Johnson vaccine? I wish to stay away from mRNA technology. I like to ask you why, first of all, but go ahead.
Yeah, I mean, I'm not sure we can kind of have a back and forth discussion.
Right.
but yeah, I mean, I respect that decision. It is a fairly new technology. I am not sure where Sinovac is approved. So depending on where you're located, I'm not sure where that is. I personally probably get the Johnson & Johnson if I were you. Part of that is I personally know more about it. So unless you're, I guess, a female under 50, you have fairly low risk associated with that. If you are a female under 50, hit me up on Twitter and we can have a more in-depth discussion on those two vaccines.
Exactly. But that's the thing. We have someone like him in here, him or her, that said, hey, I'm not vaccinating, but if I have to, which I think,
yeah,
that's all we can ask. Think about it and think about the others around you. And do you want to travel without having to wear a mask? And do you want to, oh yeah, 38. Yeah, that works, man. 38-year-old male. Perfect.
Okay, there you go.
Good
so
deal.
yeah, I would get Johnson & Johnson. The nice thing too is it's only one shot.
Yeah,
so it's quick and done.
Yep.
I think in terms of flexibility in your life, it would be easier with fairly low risk associated with that. But again, it's a personal choice, and they are,
it's lower risk than getting COVID.
Yes.
100% lower. Now I won't say 100%, but 90-something% lower risk, whatever. So I think that here's the thing that I'll say this, the DAT silencer. Okay. 0% of people have died of COVID after they've been vaccinated. Or, I'm sorry, hospitalized, and nobody has died of complications of COVID after vaccination, after whatever amount of weeks it is. I think it's 3 weeks after the second dose. There's been no reported hospitalizations and deaths.
I thought that too, boys. Yeah. I actually think that's maybe not true. I think I think the most recent statistic I saw is that there are some breakthrough cases. So a breakthrough case is after you've been fully vaccinated, you still get COVID. And that can happen usually if you don't mount a good immune response. And I think the stats I saw were, of those breakthrough cases, only 11% of them resulted in hospitalizations, but I do think 2 of them resulted in deaths.
Okay.
Or 2%, sorry. 2% resulted in deaths. I think all of the deaths I've seen were in elderly people. So people above 80.
Right. But yes, okay. So I saw a 0 out there. I was like, oh shit.
Yeah, that's what I had seen too. That's what I had seen too. But I have seen just a couple, literally less than a handful per state.
You're more likely to get hit by lightning. So
yeah, potentially. Honestly. I don't know the stats on that. So
that's 1 in a million. That's but yeah, so I appreciate the good question, man. And thank you again, Cheslea. And if we have some major breakthroughs, who knows, we might circle back around if you have time.
Yeah, we might be back, or we can touch base in a year, see what COVID looks like then.
Oh, we could do it in person.
Hey, let's hope. Let's go.
Your house. You're not too far away, I guess.
Yeah.
Or I can meet you at your parents' house. That'd be much easier for me.
Yeah, that's much closer for you, for sure.
Yes. All right, guys. Thanks again for your time, Cheslea. It's been awesome talking to you. And again, guys, if you have any more questions like this, you can always go to the hashtag #TrickleUpQs, and I can still shoot them at her. Again, go follow her on Twitter. CT Barrett, 2 T's, 05, and 2 R's.
2 R's, 2 T's.
That's right. All right, guys. So thanks for joining us, man, and go read a book.
Yeah, sounds good. Thank you, guys.